Okay, so today we're going to work on multiplication, properties of exponents, which is different from what we did yesterday. So again, if you can follow the rules, you're going to do okay. And your rules are all on the foldable that we're making right now. So before we do anything on our foldable, we're going to work on this really fast. Expanded form just means to literally make it bigger, right? So what does 2 to the first times 2 to the first mean? 2 times 2 is what it is in expanded form. And then, so that means what? It equals 4. So power of what? Yeah, 2 to the power of 2. So I want you to look for a pattern, okay? All right. 2 cubed means what? 2 times 2 times 2. Okay, 2 cubed is 2 times 2 times 2 times 2 to the first is times another 2. So it doesn't really matter to me what it equals. What I'm trying to get you to see is how many 2's are happening here. So this is really 2 to the power of 4. Okay, keep going. 2 squared, 2 times 2 times another 2 squared. So not times another 2 times 2. So that's 2 to the 4th. Notice it's the same, these two lines, the purple and the green. Okay, 2 to the 4th. So 2 times 2 times 2 times 2 times 2 times 2. So how many is that? 2 to the 6th. And our last one, 2 times 2 times 2 is 2 to the 3rd times 2 times 2 times 2. How many 2's? 2 to the 6th. Okay, so what are you noticing we are doing? What pattern do you see? Okay, that's not, yeah, we are expanding, but what's the pattern? You were right, Ivan. What did you say? Good. Yeah, 1 and 1 is 2. 3 and 1 is 4. 2 and 2 is 4. 4 and 2 is 6. 3 and 3 is 6. Notice we're not multiplying the exponents. Even though we have a multiplication sign in between, we're not multiplying the exponents, we are adding them. Are we changing the base number, the big number? No, we're not saying 2 times 2 is 4. We keep the base the same. It's 2. They're all a common base of 2. And we're just adding the exponent, okay? So now we're going to go to our foldable, because this is our first rule for today. Okay, so we're going to look at some examples that use that rule that we just put on our foldable. So, common bases is what? 11. Oh, I apologize. Y'all see it now? Okay. So common bases are 11. So what do we do with that? Keep it the same. And then what do we do the exponents? So 11 to the 7th power. Okay, and I could actually simplify that more because 11 to the 7th is a really giant number, right? Yeah, but we're not going to do that. We're just going to stop for there. Okay. Ooh. What do I do when there's like negatives thrown in there? Yeah, I mean, you just use the same rule. The base is x, and what is 7 plus negative 5? 2. Now, some of you are like, well, yesterday we learned that you bring negative 5 to the denominator, which we could do. We could do x to the 7th over x to the 5th. We're actually going to learn about what you do with this tomorrow, but this just means to subtract. 5 minus 7 is 2. Okay? But for today, just remember you are adding exponents of common bases. Okay, here's where it gets kind of weird. Because remember I told you don't multiply the bases. However, we have numbers here, the 2 and the 5, that don't have exponents. What are these numbers called? It starts with a C. Good. It's a coefficient. The coefficient is not attached to this power of 4. The power of 4 applies to the n. The power of 6 applies to the n. So the 2 and 5 are just regular old numbers. Okay, so we just multiply those regular old numbers. 2 times 5 is 10. The ones you don't multiply are the bases. The bases here are the n's. So let me clarify. So if you had 4x to the power of 3, I'm just making this up. This number here is called a coefficient. It is not your base. What is your base? The x is your base. And then the 3 is your power. Okay, the rule says you don't multiply your base. So you do multiply your coefficients just like normal numbers, okay? Unless you have a number that is your base. Do you see how 11 here is not your coefficient? 11 is your base here. The 2 and the 5 over here are your coefficients, so you have to multiply them. Okay? You all with me?
Yeah.
Okay, so we got to finish this one up. We have the 10. 2 times 5 is 10. N and n just stay as n. What do we do with the 4 and the 6? So we got 10 n power of 10. Okay, same rules apply here. Don't freak out. We have some coefficients. The 3 and the negative 5. I'm sorry, the 3 and the negative 5. What do you do with the coefficients? Multiply them like regular old numbers. 3 times negative 5 is negative 15. Okay, then we have some bases. We have two different bases. We have x and we have y. So we leave those alone. We don't put a 2 in front of them or do anything weird like that. Now we have to decide what we do with the exponents. So on the x over here, we've got a 2 as our exponent and a 3. So it's x to the 5th power. What exponent is on y? 1. If it was a 0, then the whole thing would be 1. Y to the 1st power. There's one y there. So there's y to the 1st power, and then there's y to the negative 4th. What is 1 plus negative 4? Okay. You cannot leave your answer like this. Yes, why not? This is yesterday's lesson right here. You have a negative exponent. You can't leave that. Now, can you leave this negative 15?
Yeah.
Sure, you leave that on top. Can we leave the x to the 5th? Sure, it's positive. We're good. But I have to bring my negative exponent to the denominator and make it positive. So that is the simplified version of this. This is simplified in comparison to this. Okay? So really we just applied 2 lessons. Yesterday's lesson of bringing the negative exponent to the denominator and today's lesson with adding exponents, okay? So you're going to have multiple quote-unquote rules that you're applying on this stuff. Okay. Let's keep going. 5 and 6. All right. So what's really happening here? What are these parentheses? What does that mean? Yeah, it just means we're multiplying. It's nothing fancy. It just means multiply. Okay. What do I do with this 3? Yeah, because what is it? It's just a coefficient. And there's nothing else to multiply it to, right? Except maybe like a 1. There's an understood 1 here. So 3 times 1 is just 3. Okay? All right, so what are our 2 bases we're dealing with? X and y. Okay? All right, what about our x's? Our exponent for our x's are negative 2 and 1. Yes, there's an understood 1 as an exponent. So what is negative 2 plus 1? Okay. No, negative x is different than x to the negative 1. Different things. They're not the same. Good question, though. because the negative here is multiplying times the x, and the negative here is multiplying times the power of 1. So that's not a power, and this is. Okay? No. Because remember, negative x, hold on, let me get my pens back. Negative x just means negative x. It literally means -1 times x. X to the -1 power means 1 over x. Because remember, you have to bring it to the denominator. Okay? Good questions. I'm gonna erase that. Okay. Good. All right, now we're going to deal with our y's. Exponent of y here is 3, and for a total of 6, not 9. Okay, are we done? Why not? You can't leave that negative exponent. What do we do with the 3? Leave it. What do we do with the x to the -1? Bring it down. Do I have to write a 1 up here? No, but I can. I could either write x to the 1 or just x. It means the same thing. Okay? And then y to the 6. Leave it. Leave it up top. And I'm done. Remember, if it's -1 power, what did we just talk about? Remember, oh, you were talking about leave it as a -1. Remember, when you bring it down, it changes to a +1. So you could have this here. It means the same thing. Okay? All right, last one here is 2 to the n times 2 to the n plus 2 times 2. Well, okay, are the 2's coefficients or are they bases? They're bases, so we don't multiply 2 times 2 times 2. We leave it alone, right? So what are our exponents? N plus 2, and 1. So we're literally just adding all those things together. Combining like terms. So how many n's do we have? 2n plus 3. And it's all in your exponent. And that's it. We don't simplify that. You see what I did? I just added exponents. This is an n. This is an n plus 2. This is a 1. So these are the exponents. I'm adding them together because my rule says common bases add exponents. 2n plus 3. Any questions on? That's rule number 1 we're learning today. We're learning more than one rule. And it all has to do with multiplication. So it's kind of similar because what do you do when you multiply exponents? You're really adding them. So you're going to see that a lot of the stuff we're doing today is similar. Okay, let's move on. Okay, what's the difference here from what we were doing before? There's a power to a power. So let's keep going. So the difference here is we're not multiplying bases, we're multiplying a power and a power. So it's literally saying x to the 3rd to the 2nd power. So literally we're saying, I can say literally a lot today, factored form. Okay? X to the 3rd times, or squared means x to the 3rd times x to the 3rd, right? We're doing x to the 3rd twice. That's what the power of 2 means here. So what is that in expanded form? Yeah, x times x times x. So 3 x's and then times x times x times x. So how many x's do we really have here? 6. Okay. All right. So what would be the factored form for a to the 5th to the 3rd? A to the 5 times a to the 5 times a to the 5. A to the 5th. That's a to the 5th 3 different times. That's what a power to a power does. So, okay, get ready. We're going to squish it in here. A to the 5th is a times a times a times a times a. Let's see if I can get it all in here. Times another a to the 5th, a times a times a times a times a, times another a to the 5th. times A times A times A times A times A. I think I got it all. Did I get it? Okay, so how many A's did I just write out? 15. Noticing a pattern? Good. And y squared to the fourth. Good. Y2 4 different times. Y2 times Y2 times Y2. Okay. So y squared is y times y, times another y squared, y times y, times another y squared, y times y, times another y squared, y times y. I know, it seems redundant, but there's a reason why. It's showing you, it's proving to you the rule. Okay, how many y's?
8.
Okay, so when you have a power to a power, what are you just doing with exponents? Look at the rule. It's going 3 times 2, 6, 5 times 3, 15, 2 times 4, 8. What? Yes, you're multiplying the exponents. Yes. When you're taking a power to a power, you're really just, it's kind of like distributing. Those are little arrows. So you're doing 2 times 3 is x to the 6th. 3 times 5, a to the 15th. 4 times 2, y to the 8th. Okay? So let's go to our foldable. Okay, so quickly do 7, 8, 9, and 10 on your own. Just see how you do. Just see how you do really fast. And then we're going to talk about them in just a second. Okay, so let's look at 7. Your base was y, and what was your exponent? No. What's your answer to the exponent? 12, thank you. Yeah, I was like 6. 6 times 2 is 12. That one's nice and basic. Okay, number 8, your base was x, and you had 4 times negative 2, which is negative 8, but I don't leave it. What do I do? Cannot leave this. I will take off points if you leave this as your answer. 1 over x to the positive 8. It becomes positive when you move it to the denominator. That's our rule from yesterday. Okay, number 9. Okay. This is kind of a PEMDAS-y situation. What do you think we're going to do first? You're going to distribute the integers here. Sorry, not the integers, the exponents here. You're going to multiply first because we have the parenthesis going on. So we have c to the 5th times c to the 3 times negative 1 power. Good. Okay. Now we don't have a power to a power situation. We have our first rule we learned. Common basis. We're multiplying. What do we do with the exponents? Add. What is 5 plus negative 3? Using my rules. Okay. The last one is kind of easy in comparison to the other ones. It's 4 to the 9th. And then it's a really big number if we put in our calculator, right? We're just going to leave it like that. Okay. This guy's a multiple choice question, number 11. If y equals x to the 5th, then what is equivalent to x to the 20th? Okay. Because if 1y is x to the 5th, then, oops, that would be not a 5. Then you're saying y to the 4th would be so each one of these is a y, right? Because it's telling us that y equals x to the 5th. Okay, so each one of these is a y. So when we have common bases, we keep the base and we add the exponent, and that's what we were looking for. Y to the 20th. I'm sorry, x to the 20th is the same thing as 4 y's. 1, 2, 3, 4. Okay. It's kind of like a little logic question right there. Okay, turn it on over. Okay, this is our last rule we're learning. So let's go to our foldable again one more time. and then fill that in for our last rule for today. Okay, so number 12, you're just distributing 5 to the powers of the x and the y. So you just get x to the 5th, y to the 5th. Okay, so 13 is a little different in that you have a random coefficient in here, don't you? That's okay. The power of 3 still applies to that. You don't multiply -2 times 3. You bring it to the power. So it's -2 to the power of 3. So this 3 applies to the power of both the base and the coefficient. So we have -2 to the 3rd power, and we have x to the 6th power times, because there's nothing going on in between here, 3 to the 2nd power, x to the 2nd power. Now we're going back to our first rule. Okay? Okay, first off, what is -2 to the 3rd power? Yeah, it's -8. X to the 6th times, what's 3 squared? 9. Okay, so we have coefficients here. What are we going to do with the regular old coefficients? Coefficients. They're just numbers. What if I told you 2 times 3? Would you add those? No. You would multiply them. So this would be -72. Numbers are numbers. Exponents are the ones that have the weird rules. So the little numbers, the exponents, now what do we do with those? Add them. So keep the x as your base, and your exponent would be 8. Well, what about, I thought you had to bring a negative to the denominator. Only on exponents. This is not an exponent. This is just a coefficient. Okay? 14. Okay, what do we do first? Do we multiply? Do we do this guy over here? What do we do this? You do the parentheses first. I mean, you could bring that down. It's not going to affect anything. So we have 2 to the 2nd power, because this is applying to the 2 and to the x. And then x to the 6 times x to the -4. Okay. What is 2 times 2?
4.
Or 2 squared. Oops. 4. And then common bases of x. What are you doing with their exponents? Add them. 6 plus -4, 2. Okay. All right. What do I do with fractions? Same thing. Yeah, it actually applies to the numerator and to the denominator of your fraction. Okay? See what I did? I applied this exponent to both the numerator and the denominator. Okay? And then we have c to the 14th, and then we have d to the 6th. Are we done? Almost. We just have to simplify this right here. What is 1 squared? 1. And what is 5 squared? 25. C to the 14th, d to the 6th. So is there anything else we can simplify? Nope. Okay. So they're not, as long as you remember the rules, they look complicated, but they're not that tricky. It's just adding or multiplying, right? Okay. What do we do first on number 16? Yeah, we're going to deal with these parentheses here because we have a power of 3. Power to a power. So this power of 3 is going to be applied to the 5. So 5 cubed. A to the 12th. B to the -6. C to the 3. And then times the rest of it. 3 times 3. A to the -8th. B to the +8th. Okay. We have big coefficients. First off, what's 5 to the 3rd? 5 times 5 is 25, times another 5 is 125, then times 3, because of this coefficient. What's 125 times 3? Okay. So 375 is our coefficient. I did 5 cubed times 3. It's 375. They're regular big numbers, so we're good. Okay, but now we have some bases here, a to the 12th and a to the negative 8. So what do we do? Okay, you add the exponents. So a to the 12 plus negative 8 is 4. Good. And then we got some b's. We have a negative 6 and a positive 8. Negative 6 plus 8 is b squared. And then we only have a 1c, so we just leave that alone, and we are done. Whew. Okay, a couple more, and then we'll finish up. Write an expression that represents the area of a rectangle with sides measuring 3x cubed y squared z and 6x y to the 5th z to the 3rd. Woo! Okay, so basically one of these is our length and one of them is our width. It doesn't matter which one, because what's our volume, our area formula? Length times width, right? So basically we're just multiplying these together. It's just, it's just wanting to make it an application problem, but there's no difference in what we've been doing in this problem. So go ahead and try that on your own really fast. You're just multiplying. There's no power to a power. Okay, so what did you do with the 3 and the 6? Okay, so what'd you get? 18. What about how many x's? 4. Yes, there's a 1 right here, remember? How many y's? 7. How many z's? 4. And we're done. That's our area of the rectangle. Because, yeah, that's a 1 right there. And this is 5 and 2 is 7. Okay, so the rest of these, I'll talk about, same rules apply with, this is actually, what is this called? These kind of numbers. Scientific notation. I'm going to talk about these tomorrow since we're running out of time. Okay? So we're going to end it here.